How do phytates stop iron absorption? Imagine a tiny barrier inside your digestive system that can influence how well your body takes in essential nutrients. Today, we are exploring a fascinating aspect of nutrition that involves plant compounds and their impact on mineral absorption. If you have ever wondered why some plant-based foods might interfere with iron uptake, this explanation will shed light on the underlying mechanisms. Phytates, also known as phytic acid, are naturally occurring substances found predominantly in seeds, grains, legumes, and nuts. They serve as a storage of phosphorus for plants and are considered anti-nutrients because they can bind to minerals in the gastrointestinal tract. When you consume foods rich in phytates, these compounds can interact with minerals such as iron, zinc, calcium, and magnesium. The key to understanding their effect lies in their chemical structure. Phytates contain multiple phosphate groups attached to a 6-carbon ring. These phosphate groups carry negative charges, which enable them to form strong complexes with positively charged mineral ions. When phytates encounter iron in the digestive system, they can bind to it, creating insoluble phytate mineral complexes. These complexes are not easily broken down by digestive enzymes, meaning the minerals become less available for absorption through the intestinal lining. The process of mineral absorption primarily occurs in the small intestine, where minerals must dissolve in the intestinal fluids and pass through the intestinal wall into the bloodstream. The insoluble phytate mineral complexes formed in the gut are too large and insoluble to pass through the intestinal lining efficiently. As a result, the amount of free, absorbable iron decreases significantly when phytates are present in high concentrations. This interaction is particularly relevant for non-heme iron, which is the form of iron found in plant-based foods. Non-heme iron is less readily absorbed than heme iron, which is present in animal products. The presence of phytates can further reduce the already lower absorption rate of non-heme iron, potentially contributing to iron deficiency in populations that relying heavily on plant-based diets. However, it is important to note that the impact of phytates on iron absorption can be mitigated through various food preparation techniques. Soaking, fermenting, and sprouting grains and legumes can reduce phytate levels by activating phytase enzymes that break down phytic acid. Additionally, consuming vitamin C-rich foods alongside plant-based iron sources can enhance iron absorption, counteracting the inhibitory effects of phytates. In summary, phytates interfere with iron absorption by binding to iron ions in the digestive tract, forming insoluble complexes that are not easily absorbed. This natural mechanism highlights the importance of food preparation and dietary choices in optimizing mineral intake and maintaining overall nutritional health.